conversion, change of phase. This is next topic, change of phase. Right. See, every substance, whatever you can imagine, can exist as a solid, can exist as a liquid, can exist as a gas. Iron, which you think is solid, if you heat it to very high temperature, it will change to liquid. That's it. No. Even you can have vapors of iron, right? So you can have vapors of iron, carbon, whatever substance you can imagine, whatever thing you see can exist in solid, liquid, as well as in gaseous phase. Obviously, there's a possibility, okay? Its chemical composition may change. Like solid, like if you compare it with water, if you think of water, if you heat it, then you get a vapor phase of it, right? And if you cool it, you get ice, solid phase of it. So vapor you can cool to obtain the water again. Water you can cool to obtain the solid, right, or ice, and converse is also okay. But if you say this is a marker, this is made up of plastic. If you think sir has said everything can be converted into liquid and then gas, so you tried heating it, you got liquid phase of it, okay. So if you condense it, you will again get solid. Sorry, if you cool it, you will again get solid plastic. But if you convert it into vapors, and then cool it, you may not get the same plastic, right? Hello. Can you hear me?
Yes, sir.
Okay. So change of phase we are discussing. The first statement I said, everything, whatever things you can imagine, can exist in solid phase as well as in liquid phase as well as in gaseous phase. Right? You imagine a solid.
Yes, sir.
If you increase the spaces between the particles, the force of attraction between the particles will decrease and it will change to liquid state. If you manage to increase the spacing between those particles further, so force of attraction will decrease further, and it will change to gaseous phase. Right? So every substance, every object can exist in all three phases. All right? Okay. So every substance may exist in solid phase, may exist in liquid phase, may exist in gaseous phase or vapor phase. Right? Hello.
Yes, sir.
Yes, sir.
So every substance exists in solid as well as liquid as well as and then gaseous phase. Right? Now, how do we convert solid to a liquid or liquid to a gas or gas to a solid or vice versa and so on? So by varying temperature and pressure, by varying temperature and pressure, we can change phase of any substance. We can convert solid to liquid, we can convert liquid to gas, we can convert gas to solid, and so on. Right? So by by varying temperature and pressure, increase the temperature, increase the pressure, decrease the temperature, decrease the pressure. So do all those things, and what you will observe, you will see the same substance exists in all the three phases. All right. Hello.
Yes, sir.
Yes, sir.
Now, what are these changes? So first I'll explain effects. So change in phase due to heating only. Due to heating only. So first I'll explain change of phase due to heating. Change in phase due to heating only. That means change in temperature. Change in temperature. Right? So first I'll explain the change in phase due to heating only. The next step I'll explain effect of pressure and change of the rule of pressure and change of phase. So let's understand how phase changes on heating. So I started with a solid, right? I took a solid object. So I took a solid. So I took a solid and started heating it. And let us draw a graph of temperature versus heating. The heat energy, heat is what form of energy? The amount of heat which is supplied to the object is measured along x-axis, this axis, and the temperature is measured along this axis, right? So at some heat content, temperature was something. If you start giving it heat, its temperature increases. So if you start heating a solid, its temperature starts increasing. Its temperature increases. Right. Now, with temperature, what increases? There's a term which I have explained, which increases with temperature. What is that?
Kinetic energy.
The kinetic energy.
Kinetic energy and randomness in the motion, right? So with increase in temperature, kinetic energy and randomness in the motion of the particle increases. So with increase in kinetic energy, sorry, temperature, with increase in temperature, kinetic energy of particles, kinetic energy and randomness and motion increases, right? As a result, space between the particles increases. As a result, these all points you must remember. Huh? As a result, space between particles increases. Between particles increases. It's something like, suppose there are particles. This is one particle, this is another particle. This vibrates and even this vibrates. So they continuously collide and there is some space between them, right? Now, if you heat it, they start oscillating with higher amplitudes. So for that, space between them should increase. No? Right? Hello? I hope everybody is listening. Hello? Yes. So respond करो नहीं तो मुझे लगता है कि बड़ा बोर लग रहा है तुम लोगों को जबकि है तो थोड़ा बोर but इतना भी नहीं है. So if you start heating a solid, take any solid, take ice or take plastic. For now, leave ice, water because there is some exception in it. So we'll discuss at the end. Other than that, take any solid, take a piece of iron block, right? So if you start heating a solid, its temperature increases, everyone knows. So with increase in temperature, what happens? Kinetic energy and randomness in motion of the particle increases. As a result, space between particles increases. Particles के बीच का space बढ़ने लगता है. All of us know every substance, everything expands on heating. किसी को भी आप heat करोगे, expands on heating. So we know this very well. Everything expands on heating. So this is actually real explanation for why everything expands on heating. If you heat something, particles absorb that energy. They start moving with higher kinetic energy. Amplitude of their vibration increases, right? So separation between them increases. As a result, everything expands on heating, right? So if you keep on heating, the spacing between the particles increases, right? With increasing temperature. Soon a stage comes, soon a stage comes, soon a stage comes when temperature stops increasing, stops increasing, right? Even though you're supplying heat, but temperature stops increasing. Temperature does not increases further, right? This is the point to which we say is melting point. A process has started. So soon a stage comes when temperature stops increasing, right? This is the point where phase starts changing. This temperature is known as, this is very important. Some tricky questions can be asked from this graph, especially in Bhumika. I hope you are there. So Cambridge, they ask like a lot of questions on this graph and on this topic, change of phase. So this temperature is known as melting point. This temperature is known as melting point. Melting point. Melting point I'll discuss separately also. For now, let me continue. So, what will happen? Now, temperature stops increasing. At this, this is some temperature. I don't know what it is. It depends on the solid. If it was ice, so it is 0 degrees Celsius, right? So temperature stops increasing. Even if you keep on supplying heat, its temperature does not increase. Here, actually phase changes from where to where? Solid to liquid. Solid to liquid. So this temperature is known as melting point. At this temperature, phase of solid changes to liquid. Okay, now, so phase of the solid changes to liquid, or substance changes
Yes, sir.
from solid phase to liquid phase. Now, this will continue till what time? This continues till entire solid has changed to liquid. Temperature does not increases. Temperature does not increases till entire solid has changed to liquid, right? So entire solid changes to liquid at this temperature, right? Clear now?
Yes, sir.
Now, the solid has completely converted to liquid. Now what? Now again
Now
you
the
start,
liquid boils.
so temperature again starts increasing. If liquid is heated, its temperature starts increasing. Temperature starts increasing. What will happen with increase in temperature? What will happen with increase in temperature? Hello.
The
So it
increase
will
in
become
temperature,
steam.
the more kinetic energy.
Again, the kinetic energy, randomness goes on increasing, right? Space between the particles again starts increasing. Force of attraction weakens again between them, right? This continues till some point. soon a temperature is arrived at which temperature stops increasing, right? So soon a point arrives when temperature stops increasing. Yeah? When temperature stops increasing, temperature becomes constant at that point. This temperature is known as boiling point. Temperature, this temperature is known as boiling point. This temperature is known as boiling point, right? So temperature
Yes,
does not
sir.
increases at this point. Then what happens? At this temperature, liquid changes to gaseous phase. At this temperature, at this temperature, phase changes from phase changes from liquid to gas. At this temperature, phase changes from liquid to gas, right? This
Yes, sir.
continues till entire liquid gets converted to gas. Right? This continues till the entire liquid. This continues till entire liquid changes to gas. So entire liquid gets changed to changes to gas, right?
Yes,
Clear
sir.
na? What after
Yes.
that?
Yes, sir.
Now
What
again,
after?
if you start heating, temperature starts increasing. Right? If gas is heated further, if gas is heated further, right? Again, the same thing will happen. Kinetic energy, temperature increases, right? Temperature increases. With temperature, what increases? Kinetic energy of particles increases, spacing goes on increasing, and it keeps on expanding. So gas keeps on expanding. Gas keeps on expanding with temperature.
So now there's no stopping point.
No, there are other phases also beyond our syllabus. I'll explain them at the end. Plasma, there's another state. Before solid also there was there are some more phases also. Fermionic condensate. I'll explain them at the end. Fermionic condensate, then Bose-Einstein
Bose-Einstein.
condensate. So there are other phases that I'll explain at the end. That is not there in our book. So this is additional thing that I'll explain at the end of the chapter. Right. What you have to remember is, as a process in your syllabus, what you have to remember is, it does not stops anywhere. The temperature goes on increasing. You can heat up to any level. You can heat up to any level. You cannot cool any object beyond certain temperature, but you can heat any object to infinite temperature. Right? Obviously, we have not attained it in our lab. Right? On Earth, we have not attained it yet, but even 6,000 Kelvin, like the surface of temperature of surface of sun, that all we have attained on Earth. So we have attained large temperatures on Earth, but not up to infinite, obviously. So heating can be done up to infinite temperature. There is no end on this side, but there is end on this side. You cannot cool any object beyond 273 minus 273.16 degree Celsius, as we have discussed in last lecture, right, which is known as 0 Kelvin. So you cannot heat any object beyond 0 Kelvin, but yes, you can heat, sorry, you cannot cool any object beyond 0 Kelvin, but you can heat up to infinite temperature. There is no end on the other side. Okay, clear?
Yes, sir. Yes, sir.
Okay, okay. Now, this is process, and opposite process can also be done. You take a gas, you start cooling it. There will be a stage when its temperature temperature becomes constant. At this point, it starts, condensation starts actually. So, gas changes its phase from gaseous state to liquid state. And once it is completely converted to liquid, if you cool it further, its temperature starts decreasing. It decreases till certain temperature, at some temperature which is actually freezing point. So liquid starts freezing. It changes its phase from liquid to solid, right, at constant temperature. This will continue till the entire liquid gets converted into solid. And now if you start cooling it, so its temperature will start decreasing. Clear? Clear now?
Yes, sir.
Yes, sir.
Okay. Now, now we'll discuss term by term. Some important things are there. For example, here specific heat word is there. In physics also this word is there, so I'll not explain in detail. I'll not go in detail. I'll just explain a little of it. Specific heat. What is specific heat? See, you want to heat some object, maybe a cube of copper. This is a copper cube. This is copper cube. So if you want to heat copper cube, and you want its temperature to increase from room temperature 27 degrees Celsius to 100 degrees Celsius. Suppose your interest is to increase the temperature of the cube from room temperature, that is 27 degrees Celsius, to 100 degrees Celsius. You know one thing very well, you have to heat it. You have to heat it, right? Or you have any other option?
No,
Hello?
sir.
No, sir.
You have to give it some heat, right? Now your question is, you came to me asking, sir, how much heat I should give to this copper cube so that its temperature increases from 27 degrees Celsius to 100 degrees Celsius, right? So your question was, how much heat should I give to this copper cube so that its temperature rises from 27 degree Celsius to 100 degree Celsius. So here comes the role of a term which is known as specific heat capacity. What is that? Specific heat capacity is amount of heat needed to raise the temperature of unit mass of any substance by 1 degree Celsius. I'll repeat, amount of heat needed to raise the temperature of unit mass of any substance by 1 degree Celsius. For example, actually you are supposed to remember for water. Water का specific heat capacity is 4.2 joules per gram per degree rise in temperature. What is specific heat capacity for water? I'll repeat. This is what you are supposed to remember. This is also the definition of calorie. Calorie is one of the units of heat, and it is defined as amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. Okay, so what does this imply? Suppose your mom asked, how much heat should I give to 100 gram of water? Yeah. Your mom gave you 100 gram of water to boil it and asked you to boil. So question was, how much heat should I give? Right? There are some methods with the help of which we can measure how much heat I have supplied. That is in 10th standard or other topics, other chapters, right? So forget about that. My question was, your mom asked how much heat should be given to 100 gram of water so that its temperature rises from 25 degrees Celsius to 100 degrees Celsius. Now, with this information, can you measure how much heat is needed?
Yes, sir.
Say how much heat is needed. Hello. Tell me. How much heat is needed? 4.2 joules per gram is needed. How many grams you have taken?
100.
4.100. So 4.2 into 100. For 1 gram, I need 4.2 joules. So I have taken 100 gram. So 4.2 into 100. 4.2 joules is needed for 1 degree rise in temperature. How many degrees you want to raise the temperature? Raise the
75.
temperature by
75.
75. So this is per degree rise. This is for 75. So this is 300 by 4, 1.05, 3.15 into 10 raised to 4. That's the answer. So 31500 joules. 300 by 4, 1.05, 100. Correct. So 31500 joules. That's the answer. So you can tell your mom that to heat 100 gram of water from 25 degree to 100 degrees Celsius, you need to supply 31,500 joules of energy. Is it clear?
Yes, sir.
Okay.
Sir, can you
So I'll
explain?
sorry.
Can you explain
Uh,
again?
just remind me. I'll explain in next class because in 4 minutes I have another class. I'll explain in next class.
Okay, sir.
Okay. So I'll stop here.